Welcome to Study Loop.
So in this problem, we are given the reaction equation of these two reaction with their Kc values, and we have to find out the Kp value for this reaction. So now if we look at these two reactions very carefully, we will see that this reaction is basically the sum of these two reactions, but just you have to do a single change or modification here. So in this reaction we can see that N2 and O2 are in the reactant side, but in this reaction N2 and O2 are in the product side. So if we want to write down this reaction as sum of these two reactions, what we have to do is we first have to reverse this reaction, and in that case the Kc value will also be the inverse of this value. So if we write down the second reaction in reverse form, it will be N2 plus O2 will give us 2NO, and the Kc value for this reaction will be the inverse of the Kc value of this reaction. So it will be 1 over 2.1 times 10 to the power 30, and this will give us a value of 4.762 times 10 to the minus 31. Now if you write down the second reaction here, which is 2NO plus Br2 is equal to or in equilibrium with 2NOBr, and the Kc for this reaction is 2. Now if we just add up these two reactions, we can cut this 2NO, and the overall reaction will be N2 plus O2 plus Br2, and this will give us 2NOBr, and the Kc value for this reaction will be simply the product of the Kc value of these two reactions. As we know that the equilibrium constant of a reaction, which is sum of a few other reaction, is basically the product of the Kc value of those reactions. So it will be this value times 2, and this will give us a value of 9.524 times 10 to the power minus 31. So this is the Kc value for this reaction. Now you have to find out the Kp value for this reaction. So you know that there is a relation between Kp and Kc. Kp is equal to Kc RT whole bracket del N. And here we know the value of Kc, which we just calculated. R is the universal gas constant. The value of T is given in this problem as 25 degrees C, or 298 Kelvin. It is given in Kelvin. So we know the T, and now we have to find out the value of del N. So from the balanced equation, we can see that, so as we know that del N is basically the difference between the number of molecules of the products and the number of molecules of the reactants. So here we have one N2, one O2 reacting in the reactant side, that means, and one Br2. So the sum of the molecules in the reactant side is 3, and in product side we have 2 NOBr. That means the value of del N for this reaction will be 2 minus 3, which is equal to minus 1. So the value of del N is minus 1. Now, so the value of Kp here will be the value of Kc 9.524 times 10 to the power minus 31 times the value of R, which is 0.0821 liter atm per mole per Kelvin, times the temperature, which is 298 Kelvin, and the power is the value of del n, which we have calculated as minus 1, and this will give us a value of 3.89 times 10 to the power minus 32. So this is the value of Kp for the reaction given.